Greetings, everybody. We are moving on to something new today. We are going to talk about mid-segments of triangles. So something new and different, kind of totally shifting gears from the proofs we've been on, and I'm sure you guys, most of you are happy to hear that. So something new, it'll be found in section 5.1 in your textbook. We are going to be talking about mid-segments of triangles. And the big question is, what is a mid-segment of a triangle? How do I use its properties to solve geometry problems? All right, so to understand midsegments, first we've got to remember midpoints. All right, this is from way back when. Do you remember we talked about a midpoint being a point like M that is halfway between or smack dab in the middle of a segment? So if M is the midpoint of segment AB, remember it divides AB into two congruent segments, or AM would be congruent to MB. All right, that is a midpoint. So let's not forget that. Midpoints, we worked with them. Hopefully we remember them. Okay, moving on. What happens now if we take the sides of a triangle and find their midpoints? So what I have here, side AB of this given triangle, triangle ABC, has a midpoint D, and as is with every midpoint, it divides side AB into two congruent halves, side AD and side BD. All right, so D is the midpoint of side AB. On this other side, E is the midpoint of side BC. It divides BC into its two congruent halves, BE and EC. Now, this line here, segment DE, I'm sorry, segment, not line, segment DE is what is called a midsegment. A midsegment of a triangle is a segment that connects the midpoints of two sides of a triangle. DE is a midsegment. If D is the midpoint of AB, E is the midpoint of BC, DE is a midsegment. All right? Cool things about midsegments. DE is a midsegment of this triangle. Two important properties. One, DE is parallel to the base that it's opposite to, or to the base that it does not touch. All right? DE is parallel to AC. Second important property. DE is exactly 1/2 the length of AC. So remember those. We're going to use them a boatload now, okay? DE is parallel to AC, and DE is 1/2 the length of AC. All right, now we can use these properties for some really cool things. Since we have parallel lines cut by a transversal, we know these two angles must be congruent because they're corresponding angles, right? Same with the parallel lines over here, cut by this transversal. We know these angles must be congruent because they are also corresponding angles. All right, so angle BDE and BAC are congruent. BED and BCA also have to be congruent. They're corresponding angles. Next thing we know is that if we add a third point here, a third midsegment, F being the midpoint of AC. Now look at what we've got here. We actually have three midsegments. DE is a midsegment which is parallel to AC and is 1/2 the length of AC. Now since it's half the length of AC, and so is AF, and so is FC, we know all three of those segments must be congruent. Same thing's going to happen here. EF is a midsegment parallel to BD, congruent to BD, congruent to DA. All three of those segments. Finally, the last one here, DF, parallel to BC, also congruent to EC and BE. So take a moment to study that. All right. So pause if you need to. Make sure we understand. So Each of the midsegments is parallel to the side that it does not touch, and is also congruent to each half, equal to 1/2 of the total length of that segment. All right, I'm hoping that's making sense. All right, angles, still congruent. That one, that one, that one, and actually this one will all be congruent. Next, that, and that will all be congruent. Finally, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, so we got a boatload of congruent angles, congruent sides, congruent, well, basically congruent triangles, guys. Notice what we've got. All these congruent sides, congruent angles. We've really created 4 smaller congruent triangles, each of them with sides that are half the length of the corresponding side of triangle ABC, and with an area 1/4 of the area of triangle ABC. So 1, 2, 3, 4. 4 congruent triangles, all with an area half or 1/4 the size of the big one, all with side lengths 1/2 of triangle ABC. All right, whole bunch of neat stuff there. The rest of this is on you. I'm going to scroll through. We got about 10 pages of slides coming up here. You can work on them on your own. So I'm not going to talk a whole lot more. Up to you to see, make sure you understand what's happening here and the kinds of questions we're going to ask. So pause questions, make sure you understand them, and see if you can figure out the answers to the rest of the slides. So here we go. Triangle ABC, points D, E, and F are midpoints. So name 3 pairs of parallel segments. Pause, I'll reveal in just a moment. Ready? Here we go. Next question coming up. In triangle ABC, D, E, and F are still midpoints. Name 3 sets of congruent angles. Pause. Answer coming up. D, A, F. Oh, I didn't mean to do that. Triangle DAF. That, and that. Those 4 are congruent. Same with, oops. Same with the other 4 sets, or the other 2 sets of 4. And I'll let you look at how those work. Next. Midpoints. What is the length of DE? If AB is 14. Go ahead, pause, and then I'll reveal all 3 answers. So try and answer all 3 questions. Ready, go, here they come. Next slide coming up. 4 congruent triangles. Pause. Continuing. Next. Oh, nice one. Find the length of all 3 sides. Pause. Answer's coming. Okay, we'll explain this one. Since x plus 4 has to be 1/2 of this side. There's that equation. Meanwhile, let me change another color here. Let me go with purple. Y plus 10 must be half of 4x plus 8. Second equation. All right, so each of these equations is simplified. Sorry, I lost it. Each of these equations is simplified. And then we solve the system of equations using the substitution technique. And we will find out that x equals 5 When we plug it in, we find out that y would equal 4. All right? So reason for the importance of our algebra, guys, and why we're working on these systems of equations so much. All right, so follow along. And continuing on. Oh yeah, question asks, what is the length of the three sides? What we did on the previous slide was we found x and y, but we didn't find the lengths of the sides. To actually answer the questions, we'll find the top side by plugging in 4 and 5, find the left side using the hypotenuse or using the Pythagorean theorem. We'll find the hypotenuse, and there are our three answers. Okay, so going back, follow your algebra, system of equations, two unknowns, solve, x is 5, y is 4, plug them in to find the length of the three sides. Okay, next kind of problem. Surveyor wants to know the distance across a lake. She has a way to accurately measure distance across the land, but not across the lake, so how could she use midsegments to help her find the distance? This is what she's going to do. She's going to map out a point, a couple points, and measure from z to x, and measure from z to y. So let's just say she says she finds 960 feet from here to here, 1,080 feet from here to here. All right, moving on. What she's going to do next, she's going to measure the halfway point on each of her segments. Okay, so if we had 960, well, she's going to figure out whatever half of that is, 480. And if we had 1080, she's going to figure out 540 here. And she's going to mark points A and B. Using points A and B, she's now going to measure this distance here. And she's going to find out, let's say, for example, that that's 200. Well, that is a midsegment. Therefore, the parallel side over here must be twice as great, or 400 feet across the lake. All right? And finally, write a good summary. Be ready to work on midsegments in class tomorrow.